Green Building Council happens to be a global network of green building councils with more than 75 countries as its members. So I am speaking from the Center of Excellence, which is situated in Hyderabad, the CII Saurabhji Godrej Green Business Center. It is the first platinum-rated green building in India, and it was formed as a unique public-private partnership between CII, the then combined government of Andhra Pradesh, USAID, and Firoz Shah Godrej Foundation. The main activities which we adhere to from this center are, this Center of Excellence basically deals with policy and advocacy and different programs related to energy, environment, green buildings, renewable energy, water and climate change activities which are happening in India. So I request all the participants, whenever they are in Hyderabad, please do make a visit to our center. We are situated in the heart of the financial district, that is the high-tech city. Now coming to the presentation, what do we mean by water wisdom? And I would like to share my perspective in context to the building sector. So if you see, water is an essential and an integral part of our life. And most of the time, we take it for granted unless and until there is a scarcity. And as we are seeing, cities are expanding, the pressure on the water resources is also increasing. As summers are set in, there is no regular municipal supply of water to many districts of our country. And here, when it comes to use of water in terms of construction, buildings play a vital role. And the shift has to happen from consumption to conservation. So this session explores on how thoughtfully design and responsible choices can help us value every drop of water. And henceforth, after this presentation, as listeners and as stakeholders, we do take due diligence as and when we are trying to use the precious resource, which is water. So if you see the statistical data in terms of what is happening globally in terms of water, the global water crisis in the world's water in 2026, if we see that the earth is having 70% of water, but there is only 2.5% of fresh water. Out of the 70%, 68.7% glaciers and ice caps take place. Then you have 30.1% going for groundwater and 1.2% to the surface water. It is seen that currently 25% of the population is facing water scarcity, and about 3.6 billion people are without safe sanitation. This is very alarming. It is also seen that only 60% of the water is safe, whereas 40% of the water remains to be still unsafe. And over a period of time, it is seen that there has been a lot of displacement happening, water stress, which is an alarming number, goes to 700 million. And it is expected that by 2040, 1 in 4 children will live in areas of extreme water stress. All these aspects which have been mentioned in this particular slide help us to understand that how judiciously we need to use this particular resource. So this is a particular slide which speaks about what is the freshwater scenario in India in context to the year 2025-26, taken from the different resources like the Central Water Commission, CWC, and the different areas where we are seeing that there is something which is alarming. If you see the urban demand, it is rising sharply in all our metropolitan cities like Delhi, Bangalore, and Hyderabad. At the same time, the regional distribution of water across east and west, especially our rivers, is also seen. And the scarcity is felt a lot in west and south region because there is uneven availability of water across the basins. And what do we see from the future perspective? We see that the per capita availability is projected to be less than 1,000 meter cube per person per year by 2050. And India as a country by that period of time will be labeled as a water scarce country, which happens to be very alarming for all of us. And we need to take judicious measures in order to conserve this resource. These are few paper clippings which I could come across as I could understand or when I started making this presentation. So these pictures actually showcase that how many of our counterparts or many of our own people are facing the realm of scarcity. At the same time, it is seen that water also plays a very significant role in the per capita income as well as the amount of time people spend. As you can see, women and girls are said to spend more than 250 million hours per day just for collecting water, that is potable water. At the same time, our Indian reservoirs, because of the extreme heat and the climate change which we all are facing, especially we could see a lot of change in the last week when Hyderabad went through a very bad hailstorm, especially which was not expected in the month of March. So as you can see here, the climate change has a significant effect on our resource, that is water, and we need to take due vigilance as we use it. This is also an image, or this is also a slide which speaks about what is the proportion of world's fresh water. And the total surface fresh water is only 0.4%, which is potable or drinkable. The global scenario, if you see, this was a statistical analysis which was conducted over a period of time as the population went on increasing, how the water availability went on decreasing. And this was an analysis which was conducted across the globe. And if you see India, the amount of water available per capita cubic meter in the year 1962 was 3,091. And by the year 2015, it came down to 1,118. And in 2025, it is still reached a lower stage. But there is significant amount of work which is also happening where people are taking care that we try to replenish our water resources. So this is the water demand and supply which most of the metropolitan cities across our country face. And if you see in the state or in the city of Hyderabad, you will see that the demand is about 885. But the supply is only 707, and there is a shortage of 20.08%. This particular chart represents that how the water resource is going to be scarce and how the supply and demand are slowly becoming inversely proportional. This is the diagram taken from the Niti Aayog report, which was published in 2019, which briefed that by 2020, the demand would be 1498, whereas the supply will be only 744, which happens to be very alarming. So you can see that the overall demand is expected to exceed supply two-folds by 2030, which is just 5 years down the lane. So when it comes to water requirement in buildings, this is a chart which has been given, and the source from where it has been taken is the National Building Code of India, published in 2016. As a ready reference. And it is said that when you are using commercial spaces like offices, the domestic per day demand will be 25 per head. For flushing, the demand will be 20 liters per head. And the total consumption per day liter for an individual person would be 45 liters per head. So how is water broadly used and how it is being catered and what percentage goes to into what purpose? So if you see a proper water consumption pattern for a typically air conditioning building, you will see that most of the water, that is up to 50 to 60%, goes for air conditioning makeup. The second two things which are nearly equal, that is 20 to 25%, is the landscaping and the flushing purpose. So as you can see, the air conditioning making, the heating and the cooling systems will actually consume a lot of water. So when you come to water, and in terms of water conservation, the approach which should be used is the 3R approach. The 3R approach stands for, where the first R stands for recharge. Try to see how you are trying to recharge your water source. One of the examples which can be used and which can be implemented by all of us, till as we have rainy season to come up in the month of June and July, we can initially start using rainwater harvesting methods at our site, where we can actually save the water bodies or recharge our water body. The second important R, which is reduce. Try to see in your buildings and in your spaces where you are living, you bring in water efficient fixtures, because leakages are something which cause lot of water to be lost. If you can see most of the tankers which are moving across the city taking water, you will see half of the tankers will be releasing the water on the roads only, which is really alarming. And lastly, for the reuse purpose, you should see how you are trying to reuse the gray water once it is being treated, the treated wastewater for your different applications, thus by reducing your dependency on the municipal water or potable water. So henceforth in the presentation, I will be explaining about the intent, for what purpose it needs to be done, and how it can be applied in our projects or at our homes. So what is the intent of rainwater harvesting? The intent of rainwater harvesting is to enhance the groundwater table or increase the groundwater level. Why it is needed? It is needed so that our dependency on the municipal water gets reduced, so that we reduce our dependency on potable water for our different work purposes. So hence rainwater harvesting systems needs to be extensively used so that we reduce the dependency on municipal water. And how do you design a rainwater harvesting system? So a design of the rainwater harvesting system is done by trying to understand at least what is the one-day rainfall runoff volume from the roof and the non-roof areas happening. So typically, when we consider the water aspect in our buildings, this is the way it is considered. And these are the numbers which help you to understand what is one-day rainfall or the percentage of average peak month rainfall. The concept here which one needs to understand is, if higher is the rainfall, lower is the harvesting volume. And if lower is the rainfall, higher will be the harvesting volume which needs to be considered. So these are typical ways through which the rainwater comes down and it falls on our building. And these are the runoffs which happen on the surfaces. So when you make your surfaces sloping, when you dig in different swirls, when you have good collection ponds available, you will automatically try to save the rainwater or let the rainwater pass through the land so that it gets absorbed. So these are the different ways in which typical runoff surfaces are present or can be used in your different projects. So common runoff coefficients which are available depending upon the type surface. If you see, if the surface is cemented and tiled, the runoff coefficient is 0.95. So you have to see that how you can evaluate, firstly trying to understand what is your runoff, what is the typical surface, and the runoff volume can be calculated by a simple formula, that is surface area multiplied by the runoff coefficient multiplied by the rainfall which has been given by the IMD data sheet, and try to go to the meteorological department to understand how much rainfall has occurred at a particular place. So coming to the different strategies, how can we implement rainwater harvesting at our homes? The first and foremost strategy is to collect the rainwater. So for collecting the rainwater, there are two methods. That is, you can build a collecting pond. Okay, you can dig a collecting pond, or from all your buildings, the pipes which are trying to take the rainwater, they are kind of sent to this particular collecting pond so that the storage can happen. Second is, you can also come up with a concept of the storage tank. So as you can see here in this image, one of the schools tried to use this particular Syntex tank and connected all its pipes to the Syntex tank so that whatever rainwater was flowing through the particular building was collected in this Syntex tank. Further, you can also go for percolation of rainwater directly to the ground. Try to build percolation pits, or otherwise, if you can also collect the rainwater in borewells. So these are different options which are available, and they can help you in trying to collect the rainwater and letting the rainwater go across the drain. So these methods can be used depending upon where you are situated, what is the amount of rainfall, which climatic zone you are coming from, and try to adopt a method where you can try to make maximum use of the rainwater coming at in that particular area. Secondly, these are few of the rainwater harvesting structures which have been implemented in different IGBC certified projects. As you can see here, in one of the projects in Dehradun, the ONGC project, they tried to connect the rainwater with the drain. Secondly, in the DEL project at Coimbatore, the rainwater storage chamber was made, and whatever rainwater was coming was stored in the chamber. And in our own project that is in Hyderabad, that is our own office, that is CII Saurabhji Godrej Green Business Center, we have an 8 lakh liter capacity rainwater harvesting pond. And we have good swirls developed in the particular site. So whenever rainwater comes, the water passes through these swirls and goes into the harvesting pond. So the water which is stored in the rainwater harvesting pond is used for our landscaping purpose. Coming to the next important aspect is the selection of water efficient fixtures. Why do we need to have good efficient fixtures? The intention is to minimize the use of potable water as well as to prevent the loss of water. So whenever you are trying to select good fixtures, try to see that they are easily available in the market and they can reduce the flow of the potable water. So the design strategy for a water efficient fixture would be try to see how the flow rates are met with the basic criteria and the aggregate. If you see the conventional fixtures and the low flow fixtures, the low flow fixtures come with an advantage that they have an aerator. So whenever you try to see a flow fixture, you will feel that your hands are getting wet and you are using, but the amount of water being used as compared to the conventional fixture will always be low. So these are few baselines which have been given by Uniform Plumbing Code, which can be a ready reference for all of you. You can download the Uniform Plumbing Code, which specifies that what will be the liters per flush being used for the different types of fixtures which are available, as well as how many fixtures or a full-time requirement of fixtures would need to be made available as per your project. So these are the values, and as per your need, you can select an appropriate fixture for your application. Please keep in mind whenever you are selecting fixtures, try to see that the existing fixtures or the fixtures being selected don't have any leakages, because leakages also lead to a lot of loss of water. So coming to the selection of water which are already being used in n number of projects as well as at homes. The aerators also comes at a very low price. You can go to the plumbing shop and buy it and make it an integral part of your taps as well as your showers. At the same time, coming to low flush fixtures, try to see that you have dual flush equipments available in your homes. These particular equipments can be either sensor-based or they can also have waterless urinals. Many of the projects and at our homes also, we are having this particular concept of waterless urinals, which is available. So the waterless urinals actually helps you to save a lot of water. It has a cartridge. As the density of urine is less than the fluid which is available in the cartridge, it helps you to reduce the amount of water to be used for the purpose. Now, the next important aspect when we come to how do we use water, the next aspect important is water is used for landscaping. And design the landscape in such a way that you actually use less water. So when we say designing your landscape, we intend to say, try to plant more different types of plants in your particular landscape area. So here, as you can see, the landscape design, whenever you are making, have native plants, have drought-tolerant plants, as well as adaptive plants as a part of your landscape design. So the way in which the treated water can be used for your landscape purpose. Now, how do we manage water in terms of irrigation systems? The intent is to see that how you will reduce the demand of water for irrigation by using efficient management systems and techniques. And try to see that what type of efficient systems you are providing in terms of design. First and foremost, you should have a central shutoff valve installed for all your irrigation systems. There should be good automation which is being used. That is, you have soil moisture sensors as well as time-based controls to monitor and see whether water is being supplied at an appropriate time, and when it is not needed, it stops. As well as segregate your landscape area based upon the watering needs. Please do bring into picture drip irrigation methods to reduce water evaporation, as well as any of the innovative methods which can be used for watering so that you are able to conserve this resource. So when it comes to irrigation system, you can either use a sprinkler system where you are having an automated spray system, which is popularly used in many of the places, or you can also have a mechanical spray system. Coming to drip irrigation, we would suggest please go for soaker houses, or micro misting can also be used as one of the ways of drip irrigation, which becomes a part of the water efficient system. Coming to the last part, which is how are we going to use the grey water? So the intent here is try to see how the wastewater can be treated on site and it is not sent to the water beds as it will cause pollution of the water beds or streams which are receiving them. So one of the best ways of treating the wastewater is to recycle it and to reuse it. This will help you to reduce the dependency on the potable water or the water which you are receiving from the municipal corporation. So this can be done either by installing an on-site treatment plant to handle the 100% of the wastewater which is generated in your building. Please try to see that the quality standards should comply with the CPCB or the State Pollution Control Board norms. So in the further slides, I will help you to understand which type of wastewater treatment can be used in your particular projects or at your home. So the wastewater treatment can be done in two ways. Either go for biological treatment or you can go for mechanical treatment. So you have mechanical STPs which are installed in most of the places where the treatment can take place. At the same time, the biological treatment is again properly divided into two ways, that is by phytoremediation and by the root zone treatment. So in the biological treatment of the wastewater or the grey water, which is coming from your kitchens, from your toilets, the treatment of the water happens because of a special species of plants and there is no need for electricity, except to lift the water from the pond to a higher level. Except for that, the entire treatment of the wastewater is done because of the plant species. So phytoremediation is one of the biological methods which is popularly used. We also use phytoremediation methodology at our center. So the investment for a phytoremediation plant would be around 50,000 per meter cube. So as well as there is no operating cost, as well as there is a payback within 3 to 5 years. So what all type of water can go to this particular phytoremediation plant is that you have domestic sewage water, industrial wastewater, as well as municipal wastewater can be used. So phytoremediation, as it means, phyto stands for plants and remediation means that it is curing. So in this process, what happens is that you have a special species of plants which thrive on the gray material which is present in the particular water, which means the growth, they try to get the manure from the gray material present in the water. By absorbing the gray material, they are actually cleansing the water, and this does not require the use of any electricity for the treatment of your gray water. So the water which has been cleansed after coming out of the phytoremediation plant or the treated wastewater can be used for all these different purposes. That is, it can be used for landscaping purpose, which takes about 5 to 6 liters per square meter per day. It can also be used for flushing purpose, which is 15 to 20 liters per person per day. Or it can be used as a makeup water for your cooling tower. As we saw earlier in our slide, that about 50% of the water goes for air conditioning makeup. So the cooling tower makeup water the treated water or the treated water from this particular treatment plant can be used as a makeup water, which takes about 8 to 10 liters per ton per hour. So when you are using the treated wastewater, which is the reuse, you can actually accomplish all these three areas, at the same time reduce your dependency on the potable water. Further, as we all know, we know about submetering and metering. We have energy meters installed in our homes, which help us to understand how each and every device in our home is consuming energy. On the same lines, we do advocate that for different applications, you should also have water meters. So what are water meters? Water meters are devices which help you to understand how each and every element in context to water is consuming energy. So you can install water meters for various applications like municipal water supply, bore water consumption, treated wastewater consumption, the water consumption which is taking place for landscaping, how much water is consumed for flushing, the amount of water being consumed for air conditioning, that is heating and cooling, and how the cooling tower makeup is happening, or any other major source of water device or application which is consuming lot of water. So coming to the part, IGBC deals with development of rating systems. We have 33 different types of rating systems which have been developed. All these are green building rating systems which spread across the different typology of buildings. The ratings are voluntary in nature, and each and every rating system takes into consideration the importance of water conservation methods which should be implemented in the projects. So as a part of the IGBC Green Education Initiative, we do conduct different types of programs for students and professionals. So one of the courses which we are conducting from many years is the IGBC Accredited Professional Associate Program, which is specially for students, and it's a self-paced program, and the enrollment is open throughout the year. The second program is the IGBC Accredited Professional, is for professionals more than 2 years of experience. And in the month of April, that is from 28th April to 1st May, we are having this particular program. So interested participants can enroll. The third program which we conduct is on the life cycle assessment of buildings. So this helps us to understand what is the embodied carbon and the operational carbon being emitted from the buildings. And we are also proud to say that in association with IIT Bombay, the Green Energy Sustainability Hub, we are conducting an executive training program on net zero buildings, which will be taking place in the month of May on 28th and 29th. And last but not the least, a new program on commissioning for building systems is also coming up, which is being conducted in collaboration with the Indian Society of Heating, Refrigeration and Air Conditioning Industries. So I request all the participants who are interested to take up these programs. You can connect with us and try to understand how the systems and how systems are functioning in context to green buildings and built environment. So with this, I end my presentation. I thank the entire team at the Geetanjali College of Engineering and Technology and Dr. Sri Lakshmi for giving us this opportunity. For any further details, you can visit our website www.igbc.in, or you can write to us to the following email IDs. With this, I will stop sharing my screen. Thank you very much.
Thank you, ma'am. Thank you very much for the enlightening session.
Thank you.
I take this opportunity to thank all the participants and the management of Geetanjali College of Engineering and Technology, the faculty members and the other student coordinators who have helped me to organize this event. And I would like to thank Dr. Dhanlakshmi Madam, Dean RDNC, for providing this opportunity to organize this event. I extend my thanks to Ms. Priyadarshini ma'am for delivering such an informative and engaging session. I also extend my thanks to Ms. Srireka ma'am for her inspiring and inaugural address. Thank you all the participants. Any questions? We are ready. We are open for questions. We would like to talk to the participants. Dear participants, please respond. Any questions, anything if you want to know or ask, or any questions from the participants? Okay, ma'am. Shall we? And I will provide the feedback link to these participants. They shall share the feedback.
Yes. Thank you, ma'am. Thank you very much. Thank you.
Thank
you very much.
Bye, ma'am.